This video will demonstrate how to use the Dynamic Assimilation Technique for CO2 response curves in the LI-6800. Here's the general workflow you should use. Step 1. Turn the instrument on, install a new CO2 cartridge, and check the CO2 scrub, humidification, and desiccant columns on the back of the instrument console. Step 2. Run the system warm-up tests and allow the instrument to warm up for about an hour. After the warm-up tests are completed, set the leaf chamber environmental conditions to the ones you plan to use during the CO2 response curves. This allows the environmental conditions to be fully established by the time the warm-up period is over. Step 3. After warm-up, match the ergas and then run a CO2 range match. Run a water vapor range match if one is not present or if the water vapor range match is more than several days old. Step 4. Make sure the dynamic equations are enabled and run the Dynamic Assimilation Tuning program using the flow rate that you plan to use for your CO2 response curve. Step 5. Place a leaf in the leaf cuvette and allow it to fully light adapt. Please note that the time it will take the leaf to light adapt will depend upon leaf biology and the prior light environment the leaf was experiencing. It will likely require experimentation to determine the light adaptation period for the species you are using. Once light adaptation is complete, open a log file and run the Dynamic Assimilation CO2 response curve. We will now go over the dynamic assimilation workflow in more detail. Instrument preparation consists of several steps. First, check the cable and air hose connections between the console and sensor head, and then turn the instrument on by pressing the power button on the side of the console. Check the soda lime column by ensuring that it is properly filled with soda lime and, if indicating soda lime is used, that it is white and not purple. Check the humidification column to ensure that it is at least half full of water if using the Nafion water column, or that the Stuttgarter mass is moist and very slightly gray rather than bright white. Check the desiccant column to ensure that there is sufficient desiccant present for the day's experiments. Spent silica gel takes on a clear color while spent dryrate takes on a pink coloration. Replace spent chemicals or add water as needed, and ensure that the column threads are not filled with chemical particulates and that the caps are properly sealed onto the bottom of the columns. Add a new 8 gram CO2 cartridge to the cartridge holder and place it onto the console if needed. Finally, run the system warm-up tests located under the Startup tab. To go to the warm-up tests, go to the Startup tab and then select the Warm-up System Tests side tab to the left. Ensure that warm-up tests are shown in the selection box and then press the green Start key. These tests will take approximately 12 to 14 minutes to run. Once the warm-up tests are complete, address any failed tests if needed, and then proceed to setting the chamber environmental controls. Here we will show setting up the environmental controls on the LI-6800. Please note that your specific chamber environmental settings should be dictated by your specific experimental considerations. First, I'll turn flow control on and select a moderate flow rate of 600 micromoles per second and a chamber overpressure of 0.1 kPa. Once those are set, I will turn fan on with a setting of 10,000 RPM. Next, I will set temperature to 25 using T-air. Finally, I'm going to set CO2 to be controlled on sample at 405 parts per million. Next, moisture control will be set to 60% relative humidity. And last but certainly not least, light is going to be set to 2000 with a color spec of R80 in this case, although other color specs can be used. Here are some general recommendations for setting your environmental controls. Again, the specifics of your experimental design should ultimately dictate how you set these controls. We generally recommend moderate flow rates between 500 and 800 micromole per second. Pump and flow split should be set to auto. The fan is generally set to 10,000 RPM, and T-air should be used to set the initial chamber temperature, although T-leaf can be used once the leaf is acclimating in the chamber. Water vapor should be set to keep chamber relative humidity between 50 and 80%. For CO2, we recommend controlling on sample CO2 rather than reference for the purposes of acclimating the leaf. Generally, ambient CO2 is used as the set point. For actinic light, saturating levels between 1500 and 2000 micromole per meter squared per second are used for most CO2 response curves, unless certain experiments, such as determining C star, are being conducted. After the instrument has been on and warmed up for an hour or more, the LI-6800 infrared gas analyzers should be matched. First, we recommend that users conduct a standard point match for CO2 and water vapor. Next, a full 5-minute CO2 range match should be conducted. We recommend a water vapor range match if the point match appears to be outside of the current water vapor range match curve, or if the water vapor range match is more than 7 days old. We also recommend conducting a new CO2 range match every 60 to 90 minutes or so when running dynamic assimilation CO2 response curves. To conduct a pointer range match, first make sure the measurement screen is displayed. Then touch the green Match Ergas button on the bottom right part of the screen. This will take you into match mode. Once in match mode, you can choose to conduct a point match or a range match. First, we recommend conducting a point match by selecting the Auto button in the upper left portion of the screen. A point match will take approximately 15 to 20 seconds. When the point match is complete, run a CO2 range match by selecting Open CO2 Range in the bottom right portion of the screen. Then select Acquire and make sure the normal mode is selected. The Flow S, Flow R ratio option will generally be set between 1.13 and 1.25 and can vary a little bit between instruments. Here we are using a ratio of 1.2. Ideally, this is set so that the increasing and decreasing CO2 ramps used in generating a range match curve result in match points that overlay each other. Getting the Flow S, Flow R ratio properly tuned can take a little bit of experimentation, which can be done by using the Quick Check option. However, if the CO2 range match data points do not directly overlay each other, you can still use the results as long as the curves are reasonably close. When you're ready to initiate the CO2 range match, press the Continue button. This will start the CO2 range match procedure on your instrument. It will take approximately 5 to 7 minutes to complete a CO2 range match. Once the CO2 range match is complete, the instrument will display this results screen as shown here. A quick check of the results shows that the average difference between the down-ramping and up-ramping CO2 range match data is at or below 0.1, which indicates that the selected Flow S, Flow R ratio was suitable. However, if your average difference is higher, perhaps up to plus or minus 0.2, your results are still okay, but you may want to work on optimizing the flow ratio. The results of the new CO2 range match can be implemented on the instrument by pressing the Retain button. After pressing this button, you are taken to the CO2 range match screen, where you can rerun the CO2 range match if desired, or you can select the curve fitting options you would like to use. We recommend that Fit match be set to range rather than point. Leave the use latest match point unchecked, and you can choose either the full or partial fit interval. Here we will use the partial fit interval, although satisfactory results should be obtained using either option. Once completed, you can press the Close CO2 Range button in the lower right portion of the screen to exit and return to the main match screen of the instrument. In looking at the instrument's main match screen, you may note that the latest water vapor match point, indicated by the red marker on the range match curve, does not line up with the existing water vapor range match curve stored on the instrument. The instrument may also flash a H2O range match suspended warning in yellow text at the top of the instrument screen. If this is the case, or if the existing water vapor range match curve is older than 7 days, conducting a new water vapor range match is warranted. This can be done by touching the Open H2O Range button on the bottom right part of the screen. Touching the Open H2O Range button takes you to the main water vapor range match screen. The procedure to conduct a water vapor range match is very similar to the CO2 range match procedure. First, touch the Acquire button to bring up the range match dialog box. Again, make sure that Normal mode is selected, and note that generally good results are obtained by using the flow-S/flow-R ratio that was used for the CO2 range matching procedure, which in this case was 1.2. Then touch the Continue button to initiate the water vapor range match. The water vapor range match will then start and will require several minutes to complete. Once the water vapor range match is complete, the instrument will display this results screen as shown here. A quick check of the results shows that the average difference between the up-ramping and down-ramping water vapor range match data is at or below 0.05, indicating that the selected flow-S/flow-R ratio was suitable. The results of the new water vapor range match can be implemented on the instrument by pressing the Retain button, which will take you back to the main water vapor range match screen. When you have returned to the water vapor range match screen, you can rerun the water vapor range match if desired, or you can select the curve fitting options you would like to use. Note that the new water vapor range match data, indicated by the blue dots, and the earlier point match data, indicated by the red symbol, are now properly lined up. We will now choose our curve fitting options. Here we will fit the match data using the entire range, and we will leave the Use Latest Match Point option unchecked. Finally, we will also set the fit interval to full. Once finished, the water vapor range match can be exited by touching the Close H2O Range button on the bottom right part of the screen. This will return you to the main match screen of the instrument, which you can then exit by touching the Exit Matching button at the top of the screen here. Dynamic assimilation needs to be enabled on your instrument in order to conduct a dynamic assimilation CO2 response curve. To enable dynamic assimilation, first go to the Startup tab and select Chamber Setup. On the Chamber Setup screen, ensure that the Include Dynamic Equations option is selected. Next, select the Constants tab and then select the Gas Exchange Side tab. On this screen, you will need to make sure that Use Dynamic Equations is also checked. Dynamic assimilation utilizes 3 mathematical parameters that improve the accuracy of the technique. More details about these parameters can be found in the LI-6800 user manual. Although the LI-6800 comes with some generic or best guess parameters, we recommend that users run the Dynamic Assimilation Tuning algorithm before they run their first CO2 response curve. This tuning algorithm serves to optimize the parameters for your specific flow conditions, instrument, and leaf chamber. We recommend tuning dynamic assimilation before you run your first CO2 response curve each day. Additionally, if you change chambers or the flow rate you are using, you should run the tuning algorithm. We will now demonstrate how to use the Dynamic Assimilation Tuning program in the LI-6800. To use the Dynamic Assimilation Tuning program, first, press the Constants tab and then the Dynamic side tab. This will bring up a screen with 3 selectable options in the blue bar at the bottom of the screen. The Dynamic Assimilation Tuning program can be accessed by pressing the Utilities/Tests tab in the bottom blue bar. You will want to make sure that CO2 test current is shown among the selectable options. You can then press the green Start button. This will bring up the Dynamic Tuning dialog box, which will confirm the flow rate you are using to tune dynamic assimilation. Now, press the blue Continue button to start the tuning program. The tuning procedure will take a few minutes to complete. It will automatically generate new parameter estimates and then add them to the lookup table, which can be accessed by pressing the Details tab at the bottom of the screen. More information on the Dynamic Assimilation Tuning program can be found in the LI-6800 user manual. Once the Dynamic Assimilation Tuning program is complete, you can then press Yes to add the results to the user table. Dynamic assimilation is now tuned for the flow rate you are using. If you use a different flow rate or a different chamber, you will need to run the tuning program again. Once the previous steps are completed, it is then time to place the leaf in the leaf chamber for light adaptation and acclimation. It is important to allow the leaf enough time to fully light adapt and reach steady state conditions before starting the CO2 response curve. A light adapted leaf at steady state conditions will have a relatively stable assimilation rate over a period of several minutes and will also have relatively stable stomatal conductance. The time it takes a leaf to light adapt can be variable. The main factors determining the time needed for light adaptation are the prior light environment the leaf was experiencing and leaf biology. In a field setting, choosing leaves that were well lit by the sun prior to placing the leaf in the chamber will minimize the light adaptation time needed. There are a few steps that should be followed to set up and run a dynamic assimilation CO2 response curve. First, a log file should be opened under the Log Files tab. Then, a dynamic assimilation background program should be started. When started, the background program will open a dialog box with several options. These options include the following. The starting and ending CO2 concentrations need to be specified that will mark the 2 endpoints of the CO2 ramp. The pre-ramp wait time option sets the equilibration period at the starting CO2 concentration before the ramp starts. The CO2 ramping rate determines how fast CO2 concentration changes in the leaf chamber and thus how long it takes to complete the response curve. The data logging frequency determines how many data points are logged, and the return concentration is the CO2 concentration the leaf is returned to after the CO2 ramp is finished. We will now go over some recommendations for setting these options. Here are some general recommendations for setting the background program options. For the low CO2 concentration, set it to 5 or 10 micromole per mole instead of 0. Doing this will avoid turning off the CO2 mixer, which is disruptive to the continuous ramping procedure. The recommendations for the pre-ramp wait time depend upon the direction of the ramp, as well as leaf biology. For CO2 ramps starting at a low concentration, such as 5 micromole per mole, and then increasing, a wait time of 1 or 2 minutes should work well. For CO2 ramps that start at a high CO2 concentration and then ramp downwards, a longer wait time of 3 to 5 minutes may be required. This longer wait time is due to the fact that changing to a high CO2 concentration from ambient can sometimes induce oscillations in leaf assimilation for a short period of time, and it is best to wait until these oscillations have dampened out before starting the CO2 ramp. Whether or not oscillations will be present and how long they may last is dependent upon leaf biology. A practice run or two may be required to get the pre-ramp wait time set correctly. If oscillations in assimilation are not present, a 1 or 2 minute equilibration time should be fine. For CO2 ramping rates, we recommend setting the rate between 50 and 400 micromole per mole per minute. The return concentration should generally be set to ambient or whatever the leaf is normally grown at. Finally, please note that PAM-based chlorophyll fluorescence measurement is not possible during dynamic assimilation CO2 response curves. If chlorophyll fluorescence measurements are required, you will need to use the traditional steady-state method, which can combine CO2 response curve and chlorophyll fluorescence measurements. One of the advantages of using dynamic assimilation is that the response curve contains many more data points than a traditional steady-state response curve. The logging interval determines how fast data is logged to the instrument and therefore how many data points are contained in the CO2 response curve. The maximum data logging rate is dependent upon the hardware that is inside the instrument. For instruments with the version 1 digital board, the maximum logging rate is about 4 seconds. For instruments that have the version 2 digital board, the maximum logging rate is once per second or 1 Hz. We recommend logging at the maximum rate your instrument will allow. The main trade-off between logging rates is noise and data density. Slower logging rates will have less noise and more averaging, but will decrease the total number of data points in the CO2 response curve. Faster logging rates increase noise since less averaging is possible, but the total number of data points is increased. In general, we have found that a higher data density or higher logging rate works well, and curve fits show less parameter error when compared to curves that have fewer data points. Note, though, that faster logging does not change the mean values of the parameter estimates, just the statistical uncertainty around the parameters. We will now demonstrate setting up a dynamic assimilation CO2 response curve on the LI-6800. First, a log file should be opened. This is done by selecting the Log Files tab and then select the Logging Options side tab. On the Logging Options screen, make sure that Also Log Data to Excel file is checked so that a Microsoft Excel file is created by the instrument. Also, since a lot of data will be logged during the response curve, you should uncheck Beep when logging unless you like to hear constant beeping. Note that the matching options will be ignored during the dynamic assimilation response curve. Next, go to the Open a Log File tab. Press the New File button, name the log file, and then press Done. The log file should now be open. To start the Dynamic Assimilation background program, select the Auto Programs tab. Then, press the Program Builder button. This will bring up a directory of background programs that are present on the instrument. The Dynamic Assimilation CO2 response curve background programs are found by opening the Dynamic folder. For a single CO2 response curve with a continuous ramp, select the DAT CO2 continuous program. Highlight this program, then press the green Start BP button at the side. This will bring up the Background Program dialog box. In this example, the following options are used. Starting CO2 is set to 1605 micromole per mole, and the pre-ramp wait time is set to 4 minutes. The ending CO2 concentration is set to 5 micromole per mole. The CO2 ramping rate is set to 200 micromole per mole per minute, with a logging interval of 1 second. Note that you may have to use a different logging interval, such as 4 seconds, depending upon the hardware that is in your instrument. Finally, the return CO2 concentration is set to 410 micromole per mole. When you are finished setting the program options, press the Continue button at the bottom to start the Dynamic Assimilation CO2 response curve. With these settings, there is a 4-minute equilibration period, followed by an 8-minute CO2 ramping period, so that the total time required is 12 minutes. Please note that these settings are an example only, although they should work in many cases. However, the settings you choose may be different based upon the biology of the leaves you're measuring, as well as your experimental goals. Thank you for watching this technical support video from LI-COR Biosciences. If you need additional technical support, further resources are available at our technical support website. Alternatively, you can email the support team at envsupport@licor.com or call us directly over the phone. Technical support is available Monday through Friday during normal business hours.